Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on transformations of the plane. In the last lesson, we learned about the nature of transformation. We also learned about rigid and non-rigid motion and the type of transformation called translation. In this lesson, we are going to continue our studies by looking at another type of transformation called reflection. Are you ready, students? Let us begin. This is an example of reflection. As the name implies, this type of transformation looks as though we have laid a plane mirror on the graph to produce a figure that is the opposite of the original. A reflection is a rigid motion. Students, looking at this example, can you tell where we would have to lay the mirror on the graph to produce an image like this? Please take a moment to copy this graph and draw a line where you think the reflection must be taking place.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Here is what our line looks like, and it is expressed as y equals negative x. For obvious reasons, it is called the line of reflection, or the axis of reflection. Every point on the axis of reflection is its own image. Reflection is not a difficult concept to master, students. Let us look at a pair of examples to help us. Here are two equations. The first describes a line, and the second describes a circle. What would the coordinates of the images be if we reflected them down the x-axis? All of the y-coordinates will become inverted. The coordinates AB will become A negative B. Therefore, the images of the line and the circle would be expressed this way. Do you understand the idea? Take a moment to express the image of each shape if it was reflected down an axis of reflection defined by x equals y.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. If we reflect the two shapes down this axis of reflection, what do you think will happen? Correct. We will have to transpose the coordinates of each point. That means coordinates AB will become coordinates BA. Therefore, the line will be expressed this way. Notice the function now applies to the y coordinates rather than the x coordinates, and b is subtracted. The circle will be expressed this way. X and y have swapped the quantities that they are subtracting. Were those your answers? Great job, everyone. We can also reflect along an axis that is defined by an angle. In this diagram, the axis of reflection L is a line passing through the origin and making an angle with the positive x-axis. The slope of L is given by m equals the tangent theta, and its equation is y is equal to m times x. If we want to calculate the image of point P, we can find its coordinates through this relationship. X prime equals x times cosine 2 theta plus y times sine 2 theta. Similarly, y prime equals x times sine 2 theta minus y times cosine 2 theta. There are some exceptions to these formulas, students. Be sure to discuss them with teacher after the lesson. Here is a different type of axis of reflection. As you can see, it is not defined by an angle. Rather, it is defined by the equation y equals mx plus b, where m is any real number that is not 0. To plot the image of point P using this axis, there are 4 steps that we must follow. First, we must find the slope of the axis m. Then, we must find the equation of the L prime. It passes through point P, and its slope is the negative inverse of m. Next, we find the point of intersection between L and L prime, which serves at the midpoint of the line between P and its image. Using the intersection as the midpoint and P as the initial point, find the coordinates of the image of P. Let us try an activity, students. Working with a partner, find the image of point P when it is reflected by this axis. Do your best. I will see you in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. How did you manage? Let us check our answers together. First, it is simple to calculate that the slope of the axis of reflection is 1. Therefore, the slope of the line through point P and perpendicular to the axis is -1. L prime's equation is given by y minus 2 over x plus 5 equals -1. Thus, y equals -x minus 3. Now we must plot the point of intersection between L and L prime. -x minus 3 equals x minus 2. In other words, -x minus x equals -2 plus 3. -2x equals 1. Therefore, the x-coordinate of the intersection is -1/2. The y-coordinate is equal to the x-coordinate of the intersection -2. In other words, it is equal to -1/2 minus 2. Therefore, the y-coordinate is equal to -5/2. We have determined that the intersection of L and L prime is at coordinates 1/2 and -5/2. Remember, that is the midpoint of the line between P and its image. -5 plus x prime over 2 is equal to -1/2. If we multiply each side by -2, we find that 10 minus 2x prime is equal to 2. So 2x prime is equal to 8, meaning that x prime is equal to 4. 2 plus y prime over 2 is equal to -5/2. We multiply each side by -2 to find that -4 minus 2y prime equals 10. Therefore, -2y prime equals 14 and y prime equals -7. We have calculated our answer. The image of P prime is at 4, -7. That is all for this lesson, students. We have learned about reflection and how to reflect a point or shape using different types of axes. Until next time, thank you, teacher. Thank you, students.